Let's take a look at a very interesting problem. It says 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on, all the way to infinity. What does that equal? Many students would say, well, if you keep adding and adding, it must be infinity. A lot of students say it must be infinity, right? But that's actually incorrect. So what's the answer? The answer is negative 1/12. You read that right? It's negative 1/12. Now, many students might say, but all these numbers are positive. How could adding them up possibly result in a negative number? Well, it was a German mathematician named Riemann who proposed this. And then many mathematicians went on to prove it. Using different methods, they eventually found that it really does equal negative 1/12. Today, let's try to prove this using middle school level knowledge. This method of proof was developed by an Indian mathematician named Ramanujan. He proved it using just middle school knowledge. How did he do it? Today, I'll show you and see if you understand. First, let's solve this equation. We need to understand this equation clearly. Suppose there is a number, let's call it A. What is it equal to? It's equal to 1 minus 1 plus 1 minus 1 plus 1, and so on, repeating endlessly, an infinite loop. Let's see what this number equals. Some students might say, it subtracts, then adds, then subtracts, then adds. Sometimes it's 0, sometimes it's 1. It keeps oscillating between 0 and 1. Who knows what it's actually equal to? Let me demonstrate the method of staggered addition for everyone. A equals 1 minus 1 plus 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 minus plus minus plus, right? I can stagger it by one position. This A can also have the positive one written here, the negative one written there, plus 1 minus 1 plus 1 minus 1, and so on endlessly. You'll notice something. If you add the two together, what does 2A equal? Everyone, what does 2A equal? Doesn't the negative one and the positive one cancel each other out? The positive one and the negative one cancel each other out, right? They just keep canceling each other out endlessly. So, in the end, what does 2A equal? It equals 1. That means A equals 1/2. It hovers between 1 and 0, but this number, it just equals 1/2. Using this method, let's derive the second equation and see what this number equals. Now, some students might ask, what does this have to do with it? Let's say the number is B. It's 1 minus 2. Pay attention, now it's 2, plus 3 minus 4. Plus 5 minus 6, and so on endlessly. What does it equal? Still, we use the method of staggered addition. What does B equal? Offset by one position. Write it here. 1 minus 2 plus 3. Minus 4 plus 5, and so on without end. So, if we add the row above and the row below, what does 2B equal? Everyone, what does 2B equal? When you add the two together, doesn't it become negative 1? The pair becomes 1 minus 1, right? When you add the two, what does it become? Plus 1. When you add the two, what does it become? Minus 1. When you add them, it's plus 1, right? And this goes on endlessly. So 2B equals 1 minus 1 plus 1 minus 1, alternating minus and plus, and so on. Isn't that just everyone? Isn't it A? So 2B equals A. Right? So how much is B, everyone? A, didn't we just prove it? A equals 1/2, so doesn't that mean B equals 1/4? Everyone. So the series 1 minus 2 plus 3 minus 4 plus 5 minus 6 equals 1/4. So what does that have to do with this? It does matter. Everyone, the next step is crucial. Let's suppose the series we're trying to find is S, okay? Now, I know what B equals. Look, B equals 1 minus 2 plus 3, right? 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on, endlessly, right? B equals that much. So how do we relate S and B? Everyone. Now pay attention. Let's add S and B together. Look, what does that equal? When you add them, 1 plus 1 is 2, right? Hey, does this 2 and 2 cancel each other out? 1 positive and 1 negative? What about 3 plus 3? That equals 6. Ah, wait, that's not right. 1 minus 2. Wait, that's not correct. That's not how it was. Actually, it was S minus B. Like S minus B. Ramanujan used S minus B at the time. After subtracting B, what do you get? 1 minus 1 is 0, right? 2 minus negative 2, is that 4? So do you add 4? This is getting confusing. 3 minus 3 is 0, right? 4 minus negative 4, is that 8? For me, it definitely becomes 0. What about 6? Here, there's a plus 6, right? So does that become 12? Have you noticed the pattern? What is S minus B equal to? It equals 4 plus 8 plus 12 plus 16, and you can keep going. Add 16, add 20. Subtract 20. Add 4, 20. Right? Try it yourself. And then what is this S minus B equal to? You can factor out a 4 here, everyone. Can't you factor out a 4? 4, 8, 12. They're all multiples of 4. Each term increases by 4, right? Do the calculation on a separate page. Check it carefully, right? S minus B equals 4 times the sum of 1 plus 2 plus 3 plus 4. All the way up to infinity. Do you understand this reasoning? The board work is a bit messy, so try to prove it yourself later. Then S minus B equals 4 times this amount. And isn't this amount just S? It's the S we're trying to find, the sum of 1 plus 2 plus 3 plus 4 up to infinity. So S minus B equals 4S. Then doesn't negative 3S equal B? Just move this term over and that term over. So negative S equals negative 1/3 of B, right? S is negative 1/3 of B equal to 1/4? Then isn't it negative 1/12? Is it negative 1/42? This was actually proven by Ramanujan using just middle school knowledge. Everyone try to prove it yourselves later.